Morning. Now, in the first lesson, we learned that the Earth had this really quite complex structure, as you can see in the top corner of the screen, with the inner core is enormously hot ball of solid iron and uranium, giving off, which was about 6,000 degrees, giving off loads of heat, and that heat radiates out towards the surface. We also learned that in the kind of mantle layer, there was this process called convection currents, which is this movement due to the kind of heat gradient. What we mean by that is differences in the temperature in the kind of Earth's interior to at the Earth's surface. And one of the best ways to think about that is to think a bit about kind of boiling water on a stove. So if we imagine this diagram here, our heat is the stove. Now, what happens is when that water starts to boil, is little bubbles form around the bottom, and they rise to the surface. And what's happening in that water now? Not that we can necessarily see it, but there is convection currents. Okay, and if we were to potentially put two floats on top of that, what we'd see is them being pushed around the surface of the pan. Okay, as these convection currents are moving them due to friction. Now, and exactly the same thing's happening inside the Earth. So we learn hopefully as well that the Earth's lithosphere or crust is split into 15 tectonic plates, these solid frozen plates of rock that relative to the Earth's size and mass are quite thin actually. And we had two types here, the oceanic crust and the continental crust. Now, what's happening is as these convection currents rise from the Earth's core up towards the surface, they reach the surface, they cool down, the density reduces, so the particles become more compact as they have less thermal energy, which means they have less kinetic energy to move around, so the magma becomes more compact, causing it to become more dense and to sink. Now, what that means is there's friction between this convection currents and the Earth's crust. And this friction is what's responsible for moving these plates around the Earth's surface. Now, today we're interested in learning a bit about divergent plate boundaries. So we can see in this diagram here, our heat rising from the core with our two convection currents or our two convection cells. And along this top bit, what's going to happen is the plates are going to be pulled apart, okay, and due to the friction at the top layer of that convection current between the mantle and the lithosphere. Now, if we have a look at this picture, we can see again how that might happen. So, as these convection currents rise up from the core, the friction pulls the two plates apart, and what we get in the middle, where these plates are being pulled apart, is known as seafloor spreading. Okay, so in this diagram, the oceanic crust is being pulled apart, new magma is rising up into that gap to fill it to create new rock, new lands, and the two plates are being pushed apart. Now, here's a kind of diagram showing that, which you guys can have a go at kind of copying out into your books and labeling. Now, one example of where this happens in the world, possibly the most famous example, is known as the Mid-Atlantic Ridge. So in the Northern Hemisphere, that's between the Eurasian plate and the North American plate. And actually those plates are being pulled apart due to friction by about 5 centimeters a year. So actually the North Atlantic Ocean is growing, and we are becoming further and further away from North America. And in the Southern Hemisphere, that Mid-Atlantic Ridge goes right down, and it's between the African plate and the South American plate. But we're particularly interested today in the Northern Hemisphere because one of the things that's happened along that rift where the sea floor is being pulled apart is the magma that has risen to the surface has created a volcano. That volcano has breached the surface of the sea and created an island known as Iceland. Now, Iceland has some of the youngest rock on the Earth. Iceland as a landmass is only about 20,000 years old, which when we compare it to the UK, which is billions of years old, there's quite a difference there. So Iceland's being formed, but where these plates have split apart and the lava has bubbled and kind of erupted out through the gap. Okay, and we get what's known as shield volcanoes. So we can see on this diagram all along this split, this plate boundary, known as a divergent plate boundary, where they're being pulled apart, these volcanoes popping up. And the one we're interested in today is known as E15 or Eyjafjallajökull. And this is the one which probably is its most recent famous eruption, which happened in 2010, and we're going to be learning a little bit more about. Okay, but that's the kind of processes around how these plate boundaries and divergent plate boundaries form and what's happening there.